Okay, in this video lecture, we continue to give further examples on application of L-Hospital's rule. So we start by these two problems. So evaluate the following limits: x approaching 0 from the right, sine x over x squared, and x approaching 0 from the left of sine x over x squared. So as we said in the definition of L-Hospital's rule, the first thing is to test whether the hypothesis of the theorem holds. So hypothesis is that you can only apply it if you have either of these two cases. So when you put 0 here, we have sine of 0 over 0 squared. So this will be 0 over 0. So it is true. So therefore, this is a case of 0 over 0. So which means that L-Hospital rule can be applied. So we'll have limit as x approaches 0 from the right. The derivative of this one will give us cos x. The derivative of this one will give us 2x. So when you put in 0, so we have cos of 0, and then over 2 times 0. So this will give us 0 over, no, not 0. So this will be given by so cos of 0 is 1. So cosine of 0 is 1. So this will give us cos of 0 over 2 times 0. So this will give us 1 over 0. This is just infinity. And then, so this is positive for x greater than 0. And then the second problem, B, limit as x approaches 0 from the left of sine of x over x squared. As we have tested from the first example, go to the same function, then we know that this is the same 0 over 0 case. So L-Hospital rule applies. So then now we'll have limit as x approaches 0 from the left. The derivative of sine is cos, and then this will give us 2x. Now, if you are moving from the left, then when you put here 0, so we'll have cos of 0 from the left over 2, 0 from the left. Now remember, this will give us 1. Then from the left, this is, so it's just 0 from the left. So this is the same as negative infinity. So this is negative for x less than 0. Just recall now, please remember that infinity and negative infinity infinity and positive infinity have the same meaning. So therefore, you could have written this one as, in the first case, so we could have written, so remember, we could have written this one as, so from right, and then from right, then we put a positive sign. So writing infinity or writing positive infinity, they have the same meaning. And then next, more examples. Limit as x approaches pi over 2 of sec x over 1 plus tan x. So the first thing we test, so sec of pi over 2 over 1 plus tan of pi over 2, you realize that this is infinity over infinity. You can try to this. Remember, sec is 1 over cos. So 1 over cos. So cos of 90 is 0. So it's like we have 1 over 0 over. This is tan is the same as sine over cos. So we have 1 plus also a very large number, which is giving us infinity over infinity. So therefore, this is the case of infinity over infinity. So which means that L'Hospital rule applies. So then this will be limit as x approaches pi over 2 of, now derivative of sec is given by sec tan, and then derivative of tan is given by sec squared x. Now this is the same as, so sec and sec cancels out, so we have tan of x over, so this is the same as just limit as x approaches pi over 2 over sec x, because 1 sec and 1 sec cancelled here. And then remember, tan is the same as sine x over cos x, and then 1 over sec x is the same as cos x. So therefore, this and this cancels out. So this is the same as limit as x approaches pi over 2 of just sine x. And then when you put in direct substitution, we'll have sine of pi over 2, which is just 1. Sine of 90 degrees is just 1. Another example, calculate limit as x approaches infinity of ln of x over 2 root x. So the first thing, you put in the values first. Now, you discover that now, for this case, ln of a very big number is also a very big number. The square root of a very big number multiplied by 3 is still another very big number. So this is the case of infinity over infinity. So therefore, L'Hospital rule applies. So will be limit as x approaches infinity. When you differentiate this one, you get 1 over x. When you differentiate this one, you get 2 times a half x raised to power negative a half. So which is the same thing as saying limit of 1 over x as x approaches infinity over just 1 over square root of x. Because this and this cancels out, so x raised to power negative a half is 1 over root x. So which would be the same thing as limit as x approaches infinity of, now when you put, at this point here, we have 1 over x divided by 1 over square root of x. So it's the same thing as having 1 over x times root x. So which is the same as 1 over root x. So this 1 over root x, and then 1 over root x. When you put infinity here, so square root of a very big number is also another very big number. So 1 over very big number simply approaches 0. So therefore, the value of that limit is 0. And then another problem is limit as x approaches infinity of e raised to power x over x squared. So we test first to see whether L'Hospital rule applies. So e raised to power infinity over infinity squared. So e raised to power a big number is a very big number. When you square a very big number, you also get another big number. So this is the case of infinity over infinity. So L'Hospital rule works. So therefore, it will be limit as x approaches infinity, e raised power x over 2x. Now, when you try to do direct substitution, you have e raised power infinity over 2 infinity. E raised power infinity is also infinity. 2 times infinity is also a very other big number. So here is also infinity over infinity. So L'Hospital rule still works. So you differentiate again. E raised power x over 2. So this point here, when you do direct substitution, we have e raised power infinity over 2, just the same as e raised power infinity, which are the same as infinity. So this becomes the solution. So the limit is just infinity. And then lastly, try to test, let's try to see another problem here. So in the form of a question, can L'Hospital's rule be applied to this limit as x approaches 1 of x squared plus 1 over 2x plus 1. So remember, I'm insisting that before you start applying L'Hospital rule, you have to test for the indeterminate form, 0 over 0 or infinity over infinity. If that is not the case, then the rule can't be applied. So this is what you'll do. You just replace 1 square plus 1 over 2 times 1 plus 1. This will be 1 plus 1 over 2 plus 1, which will be 2 over 3. So the answer is now, because it is not so the answer is no. Since we do not have the determinate form, zero over 0 or infinity over infinity. So therefore, because we do not have those either of these two indeterminate forms which allows us to apply the L'Hospital rule, therefore we say L'Hospital rule cannot be applied, but the limit of this function as x approaches 1 of x squared plus 1 over 2x plus 1 is just 1 squared plus 1, 2 times 1 plus 1, 1 plus 1 over 2 plus 1, which is 2 over 3. So evaluated just by direct substitution. So you have to be very careful when you are saying you want to apply L'Hospital's rule. These two indeterminate forms must be applicable for you to apply the rule. So thank you.